Welcome once again to this YouTube channel. In this particular video, we are going to be solving a paper 6 alternative to practical, and it's May June 2023, very recent, and the variant is 61. Thank you once again for subscribing for this video. Please endeavor to continue to share with your friends so that they can also learn from this channel. So let's begin to give answers to this. So the first question talks about the process of fermentation of sugar found in plants, and then the byproduct of the fermentation is carbon dioxide gas. Okay, so the steps are listed, which we're going to use in answering the questions that follows. Okay, so let's begin with the first question. Name the item of apparatus labeled A in figure 1.1. So from your knowledge of laboratory apparatus, you should know that this is a conical flask. Okay, it's a conical flask. All right, so I think that it's very simple. Just getting familiarized with the laboratory apparatus will help to solve that problem. Explain why hot water rather than cold water is used in step 2. So step 2 involves that you add hot water to the sugar cane and to stir to dissolve the sugar in the sugar cane. So the essence of adding hot water is to dissolve the sugar faster. Okay, to dissolve the sugar faster. To dissolve the sugar faster. So hot water will dissolve the sugar faster than cold water. Name the method used to remove solids from the mixture in step 3 and draw a diagram to show how this is done. So let's go to step 3. Remove the solids from the mixture to obtain sugar solution. So to obtain solids, the most suitable method will be filtration. Okay, filtration will be the most suitable method to obtain solids. And what do you need for the process of filtration? You need a filter funnel. Okay, you need a filter funnel like this. And of course, you also need a filter paper. So I'm just going to use this to represent the filter paper. So, of course, you need something to contain what has been collected. Okay, so we try and draw the filter funnel to the conical flask instead. So the conical flask will look like this. Okay, so the conical flask, the essence of drawing the conical flask is to show that during the process of filtration, of course, it needs to be collected into something. And to explain other points I would want to explain. So when the process of filtration occurs, of course, some certain things goes in through this filter paper. So this is the filter paper, all right? And this particular part of it is the filter funnel. Okay, and what passes through the filter paper is the filtrate. Okay, and then what remains in the filter paper, because you have some particles remaining in the filter paper, that is called the residue. Okay, so this is simply the basic information about the process of filtration. And then this is the conical flask, okay, where you collect the filtrates. So this is what is expected to get the maximum marks. Of course, you have the filter paper and the filter funnel, which are the most important things there. State why the sugar solution is allowed to cool before the yeast is added in step 4. So before adding the yeast, why do we allow the sugar solution to cool? Is because the yeast cannot withstand high temperature. Okay, so why the sugar solution is allowed to cool before the yeast is added is that the yeast gets denatured at high temperature. The yeast gets denatured. So the yeast gets denatured at a high temperature. And of course, when they get denatured, they become ineffective. So you don't want such happening. That is why you need to ensure that the temperature is cool enough for the yeast to function. Describe how the appearance of the lime water changes as fermentation takes place. Now, if you check the process of fermentation, like we read from the beginning, carbon dioxide gas is produced. And the test for carbon dioxide is using lime water. So how does the appearance of the lime water changes when it comes in contact with carbon dioxide? So the lime water changes from colorless to a milky or cloudy color. A milky color. So that is how the appearance of the lime water changes. Once it comes in contact with carbon dioxide, it changes from a colorless to a milky color. Describe how the students could tell that fermentation is complete. Now, how does the student know that no carbon dioxide is no longer produced? No bubbles, okay, no bubbles seen or no bubbles observed in the lime water. So what the student needs to do is to observe the lime water. If there are no longer bubbles seen in the lime water, that means the reaction is complete. Okay. Next question. Name the process used to separate ethanol from the mixture obtained by fermentation. Of course, the process is fractional distillation. Fractional distillation. Based on boiling point of the substances involved. So fractional distillation is suitable. Okay, so move to another question, which is question 2. A lot of information are given here. It says the student investigates the reaction between aqueous ammonia and two different solutions of copper 2 sulfate. So this is a reaction between ammonia and copper 2 sulfate, labeled A and B. So the copper 2 sulfates are labeled A and B. Solutions A and B have different concentrations. Okay, so we have different concentrations. Now, the experiment details are all displayed here. Okay, so the first question, okay, we have the burette reading for the first experiment and the burette reading for the second experiment. Okay, so the difference between experiment 1 and experiment 2 is simply the use of different concentrations. That's just the difference. The same compounds are involved, but the concentrations have been varied. Now, let's see what the first question entails. Okay, we're expected to fill this table in the question. So pick out the final burette reading for experiment 1 and the initial for experiment 1, and the same thing applies to experiment 2. So let's do that. So let's go to experiment 1. What is the final reading? Final burette reading experiment 1, it is 18.123. So 18.3, it should be the answer here. So 18.3. Okay, initial burette reading of experiment 1. We count each line represents 0.1 unit. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So 0.6 for the initial burette reading. Remember, the decimal places needs to be uniform. Take note of that. So you are using one decimal place, you apply one decimal place to everything. So for the experiment 2, final reading from here is 21. So we'll just go back here and write 21.0. And then the initial reading is 9.2. So we just go here and insert 9.2. Okay, so to get the volume of aqueous copper 2 sulfate added is just to do a subtraction. Final minus initial. So the final minus the initial will give us the reading. So 18.3 minus 0.6. So that is 17.7. And then we do the same thing for the second reading, 21.0 minus 9.2, 11.8. Okay, so we have simply completed the table. Remember, everything has to be in one decimal place. Explain why the white tile is used during the titration. Okay, a white tile is used during titration to ensure that the color change is clearly seen. To ensure that the color change during titration is clearly seen. To ensure that the color change during titration is clearly seen or observed. Okay, is clearly seen. Okay, so that's why a white towel is used. Now, in experiment 2, the burette and the conical flask are both rinsed with water. The burette is then rinsed with solution B. So the experiment 1, we started with solution A. So after doing the titration with solution A, the next thing is to switch to solution B. But before you switch to solution B, you need to rinse the burette and the conical flask with water. So why do we rinse the burette and the conical flask with water? That is to clean. The essence of doing that is to clean. To clean and remove solution A. Okay, because you started with solution A, now you want to switch to solution B, you need to rinse the apparatus that you use during solution A with water so that you can clean it up and it doesn't interfere with the results. Explain why the burette is then rinsed with solution B. So remember, after rinsing with water, the next step is to rinse with solution B. So you rinse with solution B to remove the water. To remove the water, since you previously rinsed with water, so to remove the water. Okay, now the next question, describe how the result of experiment 2 will be different if the conical flask is rinsed with aqueous ammonia after rinsing with water. Now, after you have rinsed with water, remember that you are expected to add 25 centimeter cube of the aqueous ammonia. But if you, after rinsing with water, you rinse with ammonia, what happens is that before you add this 25 centimeter cube of the ammonia, there are some traces of ammonia already in the conical flask. So the moment you add 25 centimeter cube of ammonia to the rinsed conical flask, you have simply added more than 25, because the traces of the ammonia in the flask plus this 25 will increase the volume of ammonia. So when I've explained that, how do we now put that as the answer? So describe how the result of experiment 2 will be different if the conical flask is rinsed with aqueous ammonia after rinsing with water. So more of solution A. Okay, since we are dealing with solution B, so more of solution B will be used. Since more of solution B will be used, since the volume of ammonia used has been increased. Since the volume of ammonia used has been increased. So we are going to require more volume of solution B, because you have increased it from 25 to something more than 25. So to obtain a neutralization reaction or to obtain the color change, you're going to need more of solution B. And that is how it will affect the results. So you're going to expect more volume of solution B to get the desired color change. All right, so moving to the next question. The dew-sweet solution of copper 2 sulfate, A or B, is more concentrated? And explain your answer. So to do this, let's go back to the table that we did. So for solution A, we have 17.7, and for solution B, we have 11.8. So the one that is most concentrated is the one with the smallest titer value, which is 11.8. Because what that means is that a smaller volume is needed because it is more concentrated. A larger volume was needed because it is less concentrated. So in this case, we'll go and put the answer as solution B. So the one that is more concentrated is solution B. And the reason is because it has a smaller titer value. It has a smaller titer value. So a smaller titer value means it gets to the color change faster because it is more concentrated. Okay. Now, deduce how many times more concentrated this solution of copper 2 sulfate is than the other solution of copper 2 sulfate. So if you look at the table that we completed, 17.7, 11.8 are the two values we are comparing. So we want to know how concentrated one is over the other one. So we can do that by simply dividing. So we do the one of solution A is 17.7, so 17.7 divided by 11.8. So let me press the calculator here, 17.7 divided by 11.8. So it is simply 1.5 times more concentrated. So from your calculation, 1.5 times more concentrated. So 1.5 times more. Okay? So just division will tell you that. Describe how the reliability of the results of things can be checked. Reliability can be checked by repeating the experiment, and comparing the results. That is one way to obtain a reliable result, by repetition and comparison. Reduce the volume of solution A required when the experiment 1 is carried out with 10 centimeter cube of aqueous ammonia. So we are looking at solution A again. And remember that the titer value of solution A was 17.7. So what was the volume of aqueous ammonia used to obtain 17.7? Remember that 25 centimeter cube of ammonia was used to obtain 17.7 centimeter cube. Okay? So what volume will now be required if we had used 10 centimeter cube of ammonia? That is what the question is asking. So this becomes x. Let's represent it as x. So to get x, by cross multiplication, it becomes 10 times 17.7 all divided by 25. So let's press down the calculator. 10 times 17.7, okay, divide that by 25. So into one decimal place, because everything we have been dealing with is in one decimal place. So if we approximate that, we have 7.1 centimeter cube. So 7.1 centimeter cube of solution A will be needed if you are using 10 centimeter cube of ammonia. I believe that is clear. So the next question, in experiment 1 and 2, the volume of aqueous ammonia is measured using the measuring cylinder. Give an advantage and disadvantage of using a volumetric pipette instead of a measuring cylinder. Now, one advantage of volumetric pipette is it has a single volume, so it is accurate. So what we just write here is it is accurate. Because it has an exact volume, it is calibrated to measure only one volume, which makes it very accurate. But the disadvantage of the pipette is that it is quite slow. So it is slow. Okay, that's the disadvantage of using the pipette. Okay, so we move to another question. A student tests two solids, solid E and solid F. So this is information obtained from solid E about how many 5 tests were carried out. So let's see what the questions are involved. So state what conclusion can be made about solid E from the observations in test 1. So let's read what test 1 is entails. So gently heat half of the solid E in a boiling tube. Now, after the process of heating, or during the process, a solution is formed, steam is given off, condensation forms at the top of the tube. Okay, so steam here is simply water giving off. So that should tell you that solid E contains water. So solid E is a hydrated substance because it contains water. So since water is given off, that means solid E had water in it. So the heating had simply removed the water. Identify the gas produced in test 3. So let's read what test 3 involves. Test 3 says, when we warm the product of test 2 and test any gas produced, the gas turns red litmus paper blue. Now, if you don't have to guess the answer to this. There is information at the end of this paper that gives information about the test for gases, test for ions, test for metals, test for anions. So we just consult that information so that you can learn how to use the information. So you can see this, the notes for using qualitative analysis. So you have tests for anions here, you have tests for cations next, and then you have for tests for gases, and then you have flame tests for the metal ions. But our focus now is on the test for gases. So which one involves turning damp red litmus paper blue? So you see it's ammonia gas, because this is the result obtained, and it aligns with the test that was done in that for solid E. So what we need to go is to fill ammonia as the answer in the question, the previous question. So what we need to just write ammonia gas. So NH3. Okay. Now, next question. State what conclusion can be made about solid E from the observations in test 4. So let's read what test 4 involves. To the second portion of solution E, add 1 cm depth of dilute nitric acid followed by a few drops of silver nitrate. So let's take note of what was added. Dilute nitric acid and drops of silver nitrate. And when that was done, there was no change. So let's consult the information again. Dilute nitric acid and aqueous silver nitrate. Okay, so look at the information here. Dilute nitric acid and aqueous silver nitrate was added to test for chloride and a white precipitate was observed. Dilute nitric acid, now if we check for others, the test for bromide, dilute nitric acid as well is used and aqueous silver nitrate, and then a cream precipitate is observed. Now for iodide as well, dilute nitric acid and aqueous silver nitrate is used, and a yellow precipitate is observed. So in these three cases, as we can see, we see that the result is white cream and yellow precipitate while adding nitric acid and aqueous silver nitrate. When it was done in the experiment performed by the students, what we simply observed from this is that there was no change. Okay, so what it simply means is that the experiment the student performed didn't give a positive result to the test for chloride, bromide, and iodide. That is why there is no change. So to answer the question, it says state what conclusion can be made about solid E from the observations in test 4. It does not contain, so it does not contain chloride, iodide, or bromide ions. So it doesn't contain any of them. That is why it doesn't give a positive change or a positive test to them. Okay, so the next one says identify the 3 ions in solid E. So ions in solid E now. So let's go from the beginning. We've talked about this. There are no ions here. Now, the next stage is this step 2, where sodium hydroxide was added in dropwise and then in excess. So when sodium hydroxide was added in dropwise and in excess, a brown precipitate was formed, which remained when in excess of sodium hydroxide. So what we need to do now is to go and consult the information to see which one rhymes when sodium hydroxide is added and then a brown precipitate is formed. So we go all the way to the table of information, and then we go to the cations. So if you look at the cations, we have 2 categories. We have when we use sodium hydroxide, we have when we use aqueous ammonia. But our focus is on that of sodium hydroxide. So a red-brown precipitate is here, which is insoluble in excess. It rhymes with what we are saying. So that means solid E simply contains iron 3 because it aligns with the test here. So iron 3 is what we simply is one of the ions that are present there. So what we need to go do here is to write iron 3 plus. Okay, so let's identify the second ion. We have 2 more to go. So the next ion is, let's see the next step. So we are done with this. The next step is using a gas, testing for the gas, and the gas turns red litmus paper blue. So that means ammonia was present here. So let's look at the ion that is responsible for the production of ammonia. So we consult again the cations this time, and we see that ammonia produced on warming shows that this ion is present, the ammonium ion. So that means this is the second ion present in solid E. So what we need to go is to come back here and write NH4 plus. Now, the third ion is the next step. So we're done with this. The third ion, this doesn't give a change, so this is not applicable. So in the third one, we see that dilute nitric acid was added, followed by aqueous barium nitrate. And what happens is that a white precipitate was formed. So we compare it with the table. Adding nitric acid and barium nitrates, what are we testing for? What kind of ions are we testing for? So we go all the way to see that when you add dilute nitric acid and aqueous barium nitrate, it gives a white precipitate. That means you are testing for the sulfate ion. So that means this is the last ion that is present in solid E. So we have SO4 2 minus. So that is how to use the information you are given to answer the questions. It's really very simple. Now, The next question says the test on solid F. So we are done with solid E. We are going to test on solid F. Now, the information in solid F is that it is a zinc sulfide. That's the compound, zinc sulfide. That means if it is a zinc sulfide, the test is either you are testing for zinc or you are testing for sulfite. That is what is going to happen in this kind of question. Okay, so complete the expected observation. The student dissolves solid F in water to form solution F. Then the student divides it into 3 portions. So we're going to use the 3 portions to test. To the first portion, the student adds aqueous ammonia in dropwise and then in excess. So write the observation in dropwise and in excess. And just like I mentioned earlier, that you are testing for solid E, solid F rather. You're testing solid F. And because you're testing solid F, what you simply expect is you are either testing for zinc or you're testing for sulfite. So all we need to do is to consult the table for zinc or for sulfite to see which one rhymes with the test that we saw there. So let's go to zinc. Okay, when we see the test for zinc, what do we observe? It's either you use sodium hydroxide or aqueous ammonia. Okay, so in the test information that we were given, we see that what we are simply using is aqueous ammonia. So we go back to the table and pick the one that applies to aqueous ammonia. So we are not concerned with this again, we are concerned with this column. So this is where we have zinc. When we add the aqueous ammonia in drops, white precipitate was formed, but in excess, it becomes soluble and it gives a colorless solution. So all we need to do is to just copy this information into the answer. So we'll go back here again. We have an answer now that on adding dropwise, white precipitate was formed. White precipitate formed. Okay. While in excess, we see it becomes soluble and becomes colorless. Okay, it becomes soluble and colorless. So that is how to use the information. Now, to the second portion of solution F this time, the student add a few drops of acidified aqueous potassium manganate 7. So let's go and check. Since we have tested for zinc, the likely thing we are testing for next is the sulfite. So let's see, test for sulfite. Now, sulfite test is here. We are considering, you can see small volume of acidified aqueous potassium manganate 7. And what is observed? Changes color from purple to colorless. So all we just need to do is to repeat the same information under the test that we have there. So color changes from purple to colorless. That is a test for the sulfite. Okay, so now the next one says to the third portion, which is the last one, the student adds 1 cm depth of nitric acid followed by a few drops of aqueous barium nitrate. Now, whenever you see dilute nitric acid added to aqueous barium nitrate, you consult that, you see that you are testing for sulfate ion, just like we did for this test. Okay, so we are testing for sulfate ion, but there is no sulfate ion in the compound that we are dealing with. It's a zinc sulfite, not a zinc sulfate. So in this case, the observation is no changes observed or no change observed. Okay, no changes observed or no changes observed, as the case may be. Okay, so because this is a test for sulfate, but the compound we are working with doesn't contain a sulfate. I believe that's clear. So we have the last question. Solid cobalt 2 oxide is a base which is insoluble in water. Okay, solid cobalt 2 oxide is a base which is insoluble in water. It reacts very slowly with cold dilute nitric acid. Take note of this point. It reacts very slowly with cold dilute dilute sulfuric acid to form a solution of cobalt 2 sulfate. All right. Describe how to make pure dry crystals of hydrated cobalt 2 sulfate. So, for it to become hydrated cobalt 2 sulfate, it's a soluble salt. Now, you are provided with cobalt 2 oxide, dilute nitric acid, and common laboratory apparatus. So, how many marks are here? 6 marks. So, we have to write 6 good points to get the full marks here. So remember that we are giving cobalt 2 oxide, dilute sulfuric acid, and the common laboratory apparatus. So the first step, so the first mark, is to add cobalt 2 oxide, add cobalt 2 oxide and dilute sulfuric acid into a suitable container, whether a beaker or a conical flask. Okay, just add it into a suitable laboratory apparatus. Okay, into a suitable container. That's the first step you need to do. Okay, so the second step that you need, since we are preparing a soluble salt, remember the steps for preparing soluble salt. The next step is to add, ensure that the cobalt 2 oxide, okay, so let's say ensure cobalt 2 oxide is in excess. This is a very important point when you are preparing a soluble salt. Ensure that the cobalt 2 oxide is in excess. And the reason why we need to ensure that this cobalt 2 oxide is in excess is to ensure that all the acids have been used up. Okay, you don't want to have acids still left. So you keep on adding the cobalt 2 oxide until when all the acids have been used up. Okay, so that's the second mark. Then the third mark is to mix, or we say stir properly, so that there is a proper mixing. Okay, so mix or stir properly to ensure that the cobalt 2 oxide and the dilute sulfuric acid are properly mixed. Okay, now another point you need to take notice from here, it says it reacts very slowly with co-dilute sulfuric acid, and you want a situation where there is a proper mixing and there's a proper dissolution. So we could include the fourth step as warm the solution. Okay, warm gently. So warm the solution gently, just to ensure that the solution takes place, because the reaction is slow. Just to hasten the reaction a bit, you can warm the solution. Now, after warming the solution, step number 5 is to filter the mixture to remove the excess cobalt 2 oxide. So filter the mixture. So you filter the mixture to remove the excess cobalt 2 oxide that you added. Okay, so after filtering the mixture, of course, we have step number 6. That's the sixth mark here, can be merged into a lot of things. So I will simply say evaporate the mixture, evaporate to point of crystallization, evaporate to point of crystallization. Okay, evaporate to point of crystallization. Okay, wash. After evaporating to point of crystallization, okay, allow to cool, allow to cool, wash with distilled water, allow to cool. Okay, so after allowing to cool, wash with distilled water, wash with distilled water and dry. Okay, so these are the 6 steps that you could write to get the full mark in this question. So we are very careful this time to ensure that we use all the information we are giving to ensure that we have all the marks, all the information in the answer. So the first is to add the cobalt 2 oxide and dilute sulfuric acid into a suitable container. Then you should ensure that the cobalt 2 oxide is added in excess to make sure all the acids have been used up. Then you mix and stir properly. You warm the solution because the reaction is very slow. So warming it might increase the rate of reaction. And then after warming, you filter the mixture to remove the excess cobalt 2 oxide. Then you evaporate to point of crystallization, allow it to cool, wash with distilled water, and then dry in between filter papers or using a warm oven. And that will get you the full marks. I think that is all for this particular paper. Thank you once again for watching.
I want to talk about a very important YouTube channel called Ajiro Tech. Trust me, this YouTube channel is a giveaway. It's loaded with IGCSE. Trust me, you is a giveaway. This channel is helpful for your group studies, your personal studies, and it has a proven track record of producing excellent results. So do me a favor, click on the subscribe button, okay, and share this YouTube channel with your friend. Trust me, that will be the best gift that you're giving to them. Thank you very much, and I'll see you in my next video. Bye bye.